Hi all, welcome to this video. In this video, I am going to discuss about sensors and transducers and also classifications of transducers. First of all, we can see what is the definition of a transducer. Just see the definition. The transducer is a device which converts one form of energy into another form. One form of energy into another form. And this conversion process is known as transduction. Let's say for an example, in the case of a microphone. What is this microphone is doing? This microphone is receiving our sound as an input unit and it converts this sound into an electrical signal form. That means from one form to another. The sound is a physical quantity and this physical quantity is converted into an electrical signal. And also similarly in the case of loudspeakers. What is the loudspeaker is doing? In loudspeaker, it receives this electrical signal as its input and also it converts these electrical signals into corresponding sound. There also this conversion of energy from one form to another is happening. So we can say this microphone and the speaker both is a type of transducer. So this is the function of a transducer, conversion of energy from one form to another. In the first case, what is the mic is doing? The sound is the input unit. It converted into an electrical form. And then these electrical signals are modulated and it in the receiver and in the loudspeaker, it converts these electrical signals back into sound waves. So in these both cases, this transduction process is happening. So transducer is a device which converts one form of energy into another form. Clear? Then next we can go with the definition of sensor. Sensor means it's a device which produces a usable output in response to a specific quantity. Produce a usable output in response to a specific quantity. That means in the sense this sensor actually senses the physical changes in the environment. It can senses the physical changes in the environment and it can produce the corresponding output regarding the input quantity. Let's say for an example, in the case of a temperature sensor. What is the temperature sensor is doing? It senses the temperature in the environment, in the surrounding area, and it can correspond into it, can change into a usable output format. Another sensor we can say for an example, proximity sensor. Proximity sensor means it can detect the presence of an object. Where we can use this proximity sensor, that means the presence of an object. Where it comes, the main application is in reverse parking system. Other types of sensors are light sensor, color sensor. These all sensors we are using in our day-to-day life. We are seeing the real-time examples. This sensor. Okay, so this is the definition of transducer and a sensor. Next we are going to discuss about parts of transducer. Parts of transducer means this is the two parts of transducer, sensing element and transduction element. That means the transducer has mainly two parts, sensing element and a transduction element. What is this sensing element is doing? It senses the input quantity and passes this input output quantity into the sensor will generate a corresponding output regarding this input quantity, and this output of this sensing element is passed to transduction element. Here the transduction element is converting this physical quantity into an electrical signal. Okay, that means the transducer is converting this physical quantity into a corresponding electrical signal. How it is happening? This physical quantity is sensed by a sensing element. We already discussed about the sensors. This sensing element senses the input quantity and it generates a corresponding output, and this output is passed to this transduction element. This transduction element is converting this physical quantity into a corresponding electrical signal. Here I am generating this output signal in the form of electrical signal. So such type of transducer is known as electrical transducer. That means electrical transducer is the transducer which converts the physical quantity into an electrical signal. That is known as electrical transducer. Then what all things can be the physical quantity? The physical quantity can be pressure, temperature, displacement, light intensity, strain, force, position, acceleration. Anything can be measured with the help of a transduction element. Then why we are using this transducer for measuring this element? Because of it's quite difficult to find the exact magnitude of these physical quantities. These all physical quantities we cannot be exactly measured. So to measure these physical quantities, we can use a transducer. Here in this case, this input quantity is converted into a corresponding electrical signal. So this electrical signal can be measured by using a meter. It can be converted into an AC or DC measuring device. By using AC or DC measuring device, we can measure the amount of electrical signal. Okay, so that's why we are using this transducer. That means it cannot be directly measured. So this transducer convert any of this physical quantities, it can be more, any of this physical quantities into a corresponding electrical signal, and from this electrical signal we can get the output quantity as well. That's why we are using this transducer. Okay, next is classifications of transducers. These transducers can be classified as, the first one, based on transduction principle. Based on transduction principle, it can be resistive transducer, capacitive transducer, and inductive transducers. What is meant by resistive transducer? The transduction principle. That means the transduction medium can be resistive, capacitive, and inductive. This resistive transducer means this transducer that varies its resistance based on an input quantity. That means when receiving an input quantity, this transducer changes its resistance or varies its resistance, and this change in resistance can be used to measure the amount of input quantity. Let's say for an example, LDR. LDR means light dependent resistor. Light dependent resistor. This LDR is mainly used in automatic street light system. How this automatic street light is working? It's automatically turned on in the day and night time and automatically turns off in daytime. Actually, it is based on the sensor, light sensor. Light sensor. So the working of LDR is based on the intensity of light falling on this sensor. This transducer automatically varies its resistance. Let's say in the case of in the daytime, the intensity of light is more. In the daytime, so the intensity of light is more. That's why this resistance transducer increases its resistance value. This transducer, resistive transducer, increases the resistance value on daytime. Why? On daytime, the intensity of light is more. So intensity of light is more, so the resistance also high. The resistance is high means there is no current in the circuit. So in the daytime, the lights are turned off automatically. Resistance high means there is no current in the circuit. That means the lights are automatically off. Then consider in the case of night time. Night time, the intensity of light is very less. That light intensity can be sensed by using light sensor. So this night time intensity of light is very less. Okay, that's why that time this resistive transducer decreases its resistance value. Resistance value decreases means there is a flow of current. There is a flow of current means lights are automatically turned on. Like this LDR is working on. I will tell once more. This LDR is working mainly in automatic street light system. What is this automatic street light is doing? It will automatically turn on in night time and automatically turn off in daytime. That means when the intensity of light falls upon this sensor, it can sense the intensity of light, and based on this the transistor can changes its resistance, and this change in resistance can be produced as an output. That is known as resistive transducer. That means it changes its resistance value. So similarly you can define the capacitive transducer also. This capacitive transducer changes its capacitance value, changes its capacitance based on an quantity, input quantity. So from this capacitance change we will get the output, we can measure the output. Similarly, inductive transducer also. How this inductive transducer is working? The transducer changes its inductance property based on an input quantity. Based on this input quantity, the transducer, the inductive transducer changes its inductance, and by measuring this change in inductance we can measure the amount of input quantity. That is known as inductive transducer. So mainly three transduction principles are three classifications are using: resistive, capacitive and inductive. Resistive transducer, what is the resistive transducer is doing? Based on this input quantity, let's suppose here the input quantity is light. Based on this input quantity it changes its resistance value. The resistance value change can be measured by using an AC or DC, convert into AC or DC, or by using a voltmeter we can measure. And then capacitive transducer. Capacitive transducer means what? This transducer changes its capacitance based on this input quantity. Similarly, inductive transducer. This inductive transducer changes its inductance property based on this input quantity. Okay, so this is the example. This is an example of this resistive transducer and all. Then next we can move to the next classification: active and passive transducers. What is active and passive transducers? Here, active transducers means this transducer can generate an automatic voltage, generate an EMF. It can generate its own EMF in the circuit. There is no need of an external power supply. That means active transducers can generate its own EMF, its own voltage. There is no need for an external power supply. Such type of transducer is known as active transducer. Example, piezoelectric crystal. That's the term used in electronics. Piezoelectric crystal, when we are applying a force on this piezoelectric crystal, this force or pressure, we can apply a pressure on this piezoelectric crystal, and this piezoelectric crystal can generate the corresponding electrical signal in the circuit. So from this pressure itself, this piezoelectric crystal can generate a corresponding electrical signal, or EMF can be generated. So there is no need of an external power supply. Such type of transducer is known as, so there's for active we can say piezoelectric crystal. And then so the passive, so this active transducer can also known as self-generating transducers. Why it is known as self-generating? Because it can generate its own voltage in the circuit. There is no need of an external power supply. That's why it is known as self-generating transducers. Next is what? Passive. So we can assume what will be passive. What will be passive? It needs an external power supply for its operations. It can't be generate an automatic voltage. Such type of transducer is known as passive transducers. Okay. Next is primary and secondary transducers. Primary and secondary transducers means some transducers can be mechanical as well as electrical devices. This mechanical, the primary transducer is, let's suppose that I just want to convert the pressure into an electrical quantity. Let's take an example. I just want to convert the pressure into an electrical signal. So, first of all, this pressure is converted into a displacement. Pressure is converted into, first of all, the pressure is converted into a displacement. Okay, that means this is magnetic signal. Pressure is converted into a displacement. This is known as primary transducer. This is known as primary transducer. This pressure is actually, I want to convert this pressure into electrical signal. But before that, this pressure is first of all converted into displacement. This is done by a primary transducer. Then next, this displacement is converted into an electrical signal. This conversion is done by secondary transducer. This is done by secondary transducer. That means some transducers can contain both mechanical as well as electrical signals, electrical devices. So the primary transducer, what is the primary transducer is doing? The primary transducer is converting this pressure into displacement. This is the first part. This is done by a mechanical device, and so this is known as, this transducer is known as primary transducer. What is the next one is doing? Next electrical device is doing converting this displacement into an electrical signal. So that is known as secondary transducer. Okay. Next is analog and digital transducer. Analog and digital transducer means if the transducer is producing the output in the form of an analog signal, it is known as analog transducer. If the transducer is producing the output in the form of a digital form or pulse form, it is known as digital transducer. Okay, then next is transducer and inverse transducer. It is very simple. Transducer is converting a non-electrical quantity into an electrical quantity. So what will be the inverse transducer is doing? It converts electrical to non-electrical or physical quantity. It is known as transducer and inverse transducer. So these all are the classifications of transducers based on transduction principle. It can be resistive, capacitive, inductive. Based on input, the transducers changes its resistance value, either changes its resistance value or capacitance value or inductance value, and by changes in this value we can measure the output input quantity. Next is active and passive. Active transducers means the transducers can generate its own voltage. There is no need of an external power supply. It is known as active transducer. Passive means what? There is need an external power supply. Next is primary and secondary. Some transducers can be both mechanical devices and electrical devices. This mechanical devices is converted this physical quantity into an then electrical quantity into a mechanical signal, and then that is known as primary transducer. Then next stage is this mechanical signal is converted into an electrical signal. That is done by secondary transducer. Then next comes analog and digital. Output if in the form of analog, it is known as analog transducer. If the output is in the form of digital transducer, digital form, it is known as digital transducer. Transducer and inverse transducer. Okay,